The history of NETL's Pittsburgh site goes back to 1910, when the newly created Bureau of Mines in the U.S. Department of the Interior opened a Pittsburgh Experiment Station in Brewston, Pennsylvania, 12 miles south of Pittsburgh. The original purpose of the site was to investigate mining methods that would reduce fatal explosions and fires in U.S. mines. This work likely saved hundreds, if not thousands, of miners' lives. Early researchers knew how to get attention. In October 1911, they intentionally set off a massive explosion in an experimental mine to prove that coal dust alone could explode, given the right flame or spark, regardless of the presence of methane. Other contributions have changed history as well. Researchers at the Pittsburgh site helped design the trigger for the first atomic bomb. In 1943, with two competing designs under consideration, the gun model and the implosion model, the head of the Ordnance Engineering Group for the Manhattan Project, Seth Nettermeyer, traveled to Pittsburgh where they spoke to George Kistiakowsky and his team in the Explosives Research Laboratory about testing the implosion model. The collaboration paid off. The first successful test explosion of an atomic bomb using the implosion model took place in the New Mexico desert in July 1945. In the 1970s, the Pittsburgh research facilities became known as the Pittsburgh Energy Technology Center, or PETC, and were no longer a part of the Bureau of Mines. PETC pioneered work on environmental issues and energy innovations, providing workable technologies to address acid rain. In 1999, the Pittsburgh site became part of a group of labs known as the National Energy Technology Laboratory, or NETL. Today, the NETL site in Pittsburgh employs more than 500 people across 30 buildings. NETL shares the campus with the Centers for Disease Control and Prevention, the National Institute for Occupational Safety and Health, and the U.S. Department of Labor's Mine Safety and Health Administration. Much of the research carried out at this facility focuses on process systems engineering, decision science, functional materials, and environmental sciences. Research in these fields directly affects the nationwide economy and national security. A tangible example of this is NETL's Analytical Lab, which conducts research on rare earth elements, REEs, to investigate economic feasibility of recovering REEs from U.S. coal and coal byproducts. REEs are vitally important to the production of electronics, defense technology, and other items used in everyday life. The Analytical Lab's research is focused on developing process designs that minimize or reduce the environmental, safety, and health impact of radioactive and other byproducts of REEs, while optimizing the overall economic benefits of the separation and recovery process. NETL's Subsurface Experimental Lab, which focuses on enhancing carbon storage technologies using pressure vessels that simulate the pressures and temperatures found deep underground, is also located at the Pittsburgh facility. Studies in this laboratory evaluate the impact of multi-phase flow, chemical precipitation and dissolution, and geomechanical stress on flow properties. The subsurface experimental lab equipment makes it possible to accurately characterize geologic formations and predict how carbon dioxide, CO2, will behave following underground injection. Advanced power generation concepts that utilize oxy-combustion are the specialties of the researchers at NETL Pittsburgh's Combustion Fundamentals Lab. Here, scientists sample product gases from a flat flame burner operated with pre-mixed oxy-fuel with steam and CO2 dilution. The properties measured for the oxy-fuel flame provide valuable data to validate fundamental simulations of advanced energy concepts. Researchers in Pittsburgh are dedicated to finding new ways to use historic energy sources such as coal. At the COMPUTATION Materials Engineering Lab, the use of coal and coal byproducts as a manufacturing feedstock for carbon materials is explored. These materials include lightweight carbon fiber composites, carbon additives for construction materials, battery and electrode materials, and carbon nanomaterials. Both yesterday and today, the NETL in Pittsburgh has embraced the challenge to find innovative solutions to meet America's energy needs and much more.